Hey, my name is Tom, and in this video I will show you the solution to two kinds of common limit exercises in calculus, and we will use the rule of L'Hopital because these will be indeterminate limits. So let's begin. And the first one says the following: the limit as x goes to 0 of sine of x over x. First, let's check whether the rule applies or not. So we have to have a ratio of the form 0 over 0. And in our case, we do have that because the sine of 0 is 0, and of course, when you plug in 0 for x, you still get 0. So we have an indeterminate form. How's it going, Pinko? And now we take derivatives. So we have the limit as x goes to 0 of, and you differentiate the top, that gives you cosine of x, and the derivative of the bottom is 1. You don't apply the quotient rule. That is a common mistake. You're simply differentiating the numerator separately from the denominator. And now you can go at it directly. So you plug in 0, cosine of 0 over 1, of course, is just 1 over 1, which is 1. So the limit of sine of x over x is 1. And if you drew for yourself a little graph, you'd see roughly that close to 0, this line is the x function, the curved one is the sine of x, and then you see that around 0 they overlap. So the ratio of the two, when you divide one by the other, should be just about 1. Okay, let's take a look at another example. Let me separate this. Oh no, get a little dirty here. Okay, hazards of doing mathematics. Okay, let's take a look at the next one here now. The limit as x goes to 0 of 1 minus cosine of x over x. So first let's check whether this is in indeterminate form, and we can write 1 minus cosine of 0 over 0. Well, cosine of 0 is 1, so we have 1 minus 1 over 0, which is 0 over 0. So we do have an indeterminate form, so we apply L'Hopital. So the limit as x goes to 0, and you differentiate the numerators, so all that remains is just a sine function. And then the bottom, the derivative of x is just 1. And now you can plug in directly, so you have 0 over 1, which is 0. So the limit of this quantity here, as x goes to 0, is 0. The limit of the other one is 1. There you go. So thank you for watching, and have an absolutely amazing day.